Good morning, students. Today we are going to discuss some multiple choice questions of the chapter Relations and Functions. Question number 1. If A is given 5, 6, 7, R is given 5, 5, 6, 6, 7, 7, 5, 6, 6, 5, 6, 7, 7, 6. Then R is, there are four options given. Which option is correct we want to find out. But is given A is equal to 5, 6, 7. Reflexive. Reflexive means x comma x belongs to R, then x belongs to A. That means 5 comma 5, 5 comma 5 belongs to R. Next element is 6, 6 comma 6 also belongs to R. Next element 7, 7 comma 7 also belongs to R. Therefore, it is reflexive. Now, what is symmetric? What is symmetric definition? If x comma y belongs to R, then y comma x also belongs to R. X comma y belongs to A. Now observe 5 comma 5, reverse also 5 comma 5, 6 comma 6, 7 comma 7. Now you may observe 5 comma 6 belongs to R, then 6 comma 5 also belongs to R. Next 6 comma 7 belongs to R, then 7 comma 6 also belongs to R. Therefore, R is symmetric. Now we observe transitive. What is the definition of transitive? If x comma y belongs to R and y comma z belongs to R, then x comma z also belongs to R. X, y, z belongs to A. Here clearly observe that 5 comma 6 belongs to R. 6 comma 7 also belongs to R. Then what about 5 comma 7? You may observe 5 comma 7. Is it belongs to R or not? Not belongs to. 5 comma 7 does not belongs to R. Therefore, R is not transitive. You may observe which option. First, A option is reflexive, symmetric, but not transitive. Option A is correct one. Question number 2. Let R be a relation defined on Z as follows. A comma B belongs to R. A square plus B square is equal to 25. Then domain of R is, since A square plus B square is equal to 25, which implies B square is equal to 25 minus A square. Then B is equal to plus or minus root 25 minus A square. Then what is R? Let us take integers. Suppose if A is equal to 0, then B is equal to plus or minus root 25. This is equal to plus or minus 5. Suppose A is equal to either plus 1 or minus 1, you may take, because A square is equal to 1 only, plus if you take plus or minus, then B is equal to plus or minus root 25 minus A square means 1. This is equal to plus or minus root 24. This is not an integer. A is equal to take plus or minus 2. If A is equal to plus or minus 2, what is B is equal to? Plus or minus root 25 minus 2 to the 4. This is equal to plus or minus root 21. It is also not an integer. A is equal to plus or minus 3. then b is equal to plus or minus root 25 minus a square. A square is equal to plus or minus 3 whole square. 3 square is 9. This is equal to plus or minus root 16 is equal to plus or minus 4. A is equal to plus or minus 4. Then b is equal to plus or minus root 25 minus 4 whole square. Plus or minus 4 whole square is equal to 16. This is equal to plus or minus root 25 minus 16, 9 is equal to plus or minus 3. Then a is equal to plus or minus 5, which implies b is equal to plus or minus root 25 minus plus or minus 5 whole square. 5 square is 25. This is equal to 0. Now you take a is equal to plus or minus 6. Then b is equal to plus or minus root 25 minus 36. 25 minus 36 is negative number. Negative number means less than 0. Less than 0 means it is not an integer. Then what is r is equal to? If you are taking r, a is equal to 0, b is equal to plus or minus 5. Then a is equal to 1. It is not possible because b is not an integer. A is equal to plus or minus 2 also not possible because it is not an integer. B is not an integer. A is equal to take plus or minus 3. B is equal to plus or minus 4. Take A is equal to plus or minus 4. A is equal to plus or minus 4. B is equal to plus or minus 3. A is equal to plus or minus 5. Then B is equal to 0. Then A is equal to plus or minus 6. B is negative number. It is not an integer. A root of negative number. Root of negative number means here under root it is negative. Therefore, it is a complex number. Therefore, it is not an integer. Then what are the all first elements? All first elements 0, plus or minus 3, plus or minus 4, plus or minus 5. All first elements. This is called a domain. This is called domain. Which option is correct? Option C is correct. Question number 3. The maximum number of equivalence relations on the set A is equal to 1, 2, 3. A is given 1, 2, 3. Then let us take all possible equivalence relations are. First one is take 1, 1, 2, 2, 3, 3 because it satisfies reflexive, symmetric and transitive. Therefore, it is an equivalence relation. Then add these two elements 1, 2 and 2, 1. 1, 2, 2, 1 symmetric. If you are taking 1, 1, it is also there. It is transitive. Means reflexive is there, symmetric is there, transitive also is there. Next possible R3. Take 1, 3 and 3, 1. 1, 3, 3, 1. It is symmetric. Again 1, 1 also there. It is transitive. 1, 1, 2, 2, 3, 3 is there reflexive. One more possible equivalence relation. Take 2, 3, 3, 2. 2, 3, 3, 2 symmetric. Again 2, 2 transitive. 1, 1, 2, 2, 3, 3 is there reflexive. Therefore, it is equivalence relation. Finally, take all the elements. A cross A will come. Then how many possible equivalence relation? 1, 2, 3, 4, 5. The correct option is B. 5 is the correct answer. Question number 4. Consider the set A is equal to 1 comma 2. A is equal to 1 comma 2. The relation on A which is symmetric but neither transitive nor reflexive is, here there are 4 options. We have to observe one, this is 1 comma 1, 2 comma 2. It is reflexive, but it is given it is not reflexive. This is not correct option. Next, which is 1 comma 2 is there, 2 comma 1 is not there. It is not symmetric. Here, empty relation, it is 1 comma 1, 2 comma 2 is not there, but it is symmetric and transitive also. It is also not option, correct one. Then this one, 1 comma 2, 2 comma 1, 1 comma 2, 2 comma 1, it is symmetric. We know that 1 comma 1 is not there, it is not transitive. And 1 comma 1, 2 comma 2 is not there, it is not reflexive. The correct answer is D option is correct one. Question number 5. If A is equal to DEF and let R is equal to DD, DE, ED, EU, then R is, which option is correct we have to check. Since R is equal to DD, DE, ED, EE, we know that A is equal to DEF. First, whether it is reflexive or not, we will check. DD is there, EE is there, FF is not there. FF is not there. Therefore, it is not reflexive. Not reflexive. It is not reflexive means it is not an equivalence relation. Not reflexive is here only. Whether you check whether symmetric, transitive or not. DD is there, DE is there, ED is there. It is symmetric. EE is there, it was also EE. Therefore, it is symmetric. It is symmetric. Then DD is there, starting with D, DE is there. DD, DE, DE also is there. DE, ED, you may observe DE, ED, DD, DD also is there. DE, EE, DE also is there. It is transitive. Therefore, it is symmetric, transitive, but not reflexive. Option B is the correct one. Question number 6. Let R be a reflexive relation. It is given clearly, it is a reflexive relation on a finite set A having n elements. Set A having n elements. Number of elements in set A is equal to n. Minimum number of order pairs MB, minimum number of order pairs are. Minimum number of order pairs of R is equal to M. Then we know that reflexive means X comma X belongs to R. That means if there are n elements in A, means no doubt order pair should be n. Minimum number of order pairs should be n. Therefore, M is equal to n. This is the option correct. Option C is the correct one. Question number 7. Let us see what is this one. The number of elements in set A is equal to 3. N of A is equal to 3. Number of possible relations. Number of possible relations can be defined on A is. We know that number of elements in A cross A is equal to 3 into 3 because A having 3 elements, 9 elements. Number of possible relations means possible subsets. Possible subsets is equal to 2 to the power of 9. This is 2 to the power of 9 is equal to 512. Therefore, number of possible relations is equal to 512. Otherwise, you may use direct formula 2 to the power of n square. This is 2 to the power of 9. This is equal to 512. Question number 8. The number of elements in set A is equal to 3. N of A is equal to 3. Number of possible relations. What is the formula? Number of possible relations. Possible relations on set A. On set A is equal to 2 to the power of n into n minus 1. Here n is equal to number of elements in A. What is number of elements in A? Here 3. Then the answer is 2 to the power of 3 into 3 minus 1. This is equal to 2 to the power of 3 into 2. This is 2 power 6. 2 power 6 is equal to 2 cubed into 2 cubed, 8 into 8, 64. 2 to the power of 6 is equal to 64. Option A is correct one. Question number 9. The number of elements in a set P is equal to 4. That is, let us take n is equal to 4. Number of elements in set P, n is equal to 4. Now, number of possible symmetric relations are number of possible symmetric relations. Symmetric relations. What is formula? 2 to the power of n into n plus 1 divided by 2. This is the formula number of possible symmetric relations. This is equal to 2 to the power of what is n? 4 into 4 plus 1 divided by 2. This is equal to 2 to the power of 4 into 5. 20. 20 by 2 is 10. 2 to the power of 10. 2 to the power of 10 is 2 cubed into 2 cubed into 2 cubed into 2. Because 3, 3, 6, 6, 3, 9, 9, 1, 10. Otherwise, directly also multiply. This is 8 into 8 into 8 into 2. This is 8, 8, 64 into 8, 2, 16. 64 into 16 is equal to 1024. If you are multiplying 64 into 16, you will get 1024. The correct option is D. Remember this formula, please. Question number 10. Let R be a relation on set n of natural numbers defined A or B if and only if A divides B. Then which of the following is correct? Here given A divides B. A divides B. That means B divided by A. A or B means A comma B belongs to R. A divides A. A divides A. For all A belongs to natural numbers. Therefore, R is reflexive. We know that let A divides B. Let A divides B, which implies B divides A. A is not true. Is not true for all A belongs to natural numbers. Therefore, R is not symmetric. R is not symmetric. Now, let A divides B and B divides C, which implies A divides C. For all A comma B comma C belongs to natural numbers. Clearly, we know that A divides B and B divides C means A divides C. Therefore, R is transitive. Means it is reflexive and transitive but not symmetric. Let us see which option is correct. Not symmetric. Not symmetric. Here it is not symmetric. It is reflexive, transitive but not symmetric. Option C is correct one. Question number 11. Let f from R to R. R to R means real numbers to real number be defined. F of x is equal to 1 by x for all x belongs to R. Then f is 1, 1 and 2 bijective. F is not defined. First of all, we will see that f is defined or not. F of x is equal to 1 by x. X belongs to real numbers. Let us take x is equal to 0. Then because 0 is a real number, let x is equal to 0. Then f of x does not exist. Therefore, f is not defined. Correct option is D. Question number 12. Set A has 4 elements. Set B has 5 elements. Then the number of bijective mappings from A to B. Bijective function means it is bijective means n of A is equal to n of B. Here n of A is not, n of A is given 4, n of B is given 5. Here n of A is not equal to n of B. Therefore, number of bijective mappings 0. The answer is option C. Question number 13. Set A has 3 elements. That is n of A is equal to 3 elements. And set B has 4 elements. N of B is equal to 4 elements. Then the number of injective mappings. Injective mappings means 1-1 functions. Number of 1-1 functions. Otherwise, injective mappings. Is equal to n of B P n of A. P means permutations. This is n of B is 4, P 3. This is 4 factorial divided by 4 minus 3 factorial. This is 4 factorial means 4 into 3 into 2 into 1 divided by 4 minus 3 is equal to 1 factorial. 1 factorial is equal to 1. This is equal to 4 3 is 12, 12 2 is 24. Number of injective mappings 24. Correct option is C. Answer is 24.